Okay, so today is to do a little example and to try to understand how hash functions are used in digital signal eh, authentication. Let's call it digital signature. How can I use the hash functions to make digital signature? The hash function, I talk about functions like sh1, 2, 3. The idea of them. The idea is that this hash function should take a, let's call it a text, A is a text, hello world, and convert it to a hash value, f7, 8, blah blah blah, 9, 7, that looks very random. Now, this function is deterministic, so for each hash text, we will always, using the same hash function, get the same value. So the idea of using hash function to use it for digital signature is, if I have a message, let's call it again A, this is my message, or let's call it M, it is more uh, probable. And I use, for example, RSA for encryption. So, and I have a message which is M, and I want to send it, and I want to sign it, that the receiver will know that it came from me and not from an attacker, from Oscar. So what I do is I do all the RSA idea. I get a key for encryption, key for decryption, a private key and everything. I use the, let's call it the private key, and this is the public key, or both are P. So this is private and this is public. So I use this private key to encrypt my message after I hashed it. So I have M, I hash the message, then I hash, then I encrypt. So I do H M to let's call it a private key. So let's take D. Then I send the message, and the encrypted hash value, let's call it HMD, and the receiver gets it. And what he does, in order to identify that the message really came from the one that sent it and not from an attacker, what he does, he decrypts the hashed value, namely he does HM to the D and use the public key E, and then he gets H of M. Then what he does, he also hash the message he got, M, and try to see if it matches the H of M. If it matches, if match, so great, we know that we got it from the receiver. If not match, so we know that something is wrong with that signature, and we say that something is wrong. Every little thing that we will change in the message should change the hash function. Now, there is attacks that can be used on those hash functions, like collision attacks using the birthday paradox. We have videos on this, but there is those attacks because the hash function is finite. Namely, we have finite set of hash values, and we have should have infinite texts in the text that you can create. So we have some collisions. We must have collisions. Every hash function should have collisions, but we need a good hash functions that the probability that we will get it are very low. But this is the idea of the hashing and how it can be used on a signature on a message, and send this message to the receiver. And when I said E and D, I meant K of E and K of D. Okay, this is D, this is E. So message, hash it, encrypt it, let's call it D, send it in the receiver, decrypt, hash the message, see if it fits the hashing, and if yes, great. Now, in order for this to happen, the attacker will have problem to create this. This is the idea. The attacker can know the message, can know this value, but if there is a change in the hashing, the receiver will use the public key and won't get the hash, so it won't be the same, and you will know that there is something wrong with the message. Okay, so this is the idea of using hash functions in digital signatures, using, for example, the RSA encryption method for digital signature authentication. Thank you very much. If there are any mistakes or corrections, please tell me. And that's it.